G'day and welcome to Mark and Sam After Work. Today I want to bring another information video to people, going through and explaining a little bit about your barrel chambers and custom chambers and bits and pieces like that, and some of the details that are involved around that. A video really for the novice to go through that process and help them, and there's probably a little bit for the advanced shooter as well out of some of the information that I've gleaned over the years of doing what I do. Before I go any further with video, I would like to point out to people, we bring these videos, we try and help as much as we can the gun community, want to support that side of things all over the world, but largely out of our own pockets. We get very, very little from YouTube. We are, I don't know, seemed as dangerous or something along those lines with the extreme long range shooting, so they're not a big fan of what we do, but we still use it as the best platform. But it means we really need help to be able to keep doing what we're doing. So if you can donate, if you can support to us, we'd be very, very grateful for it. Our pockets are only so deep and we work pretty hard at trying to do this. Anyway, no, I don't want to be begging, just I need to say that occasionally. So let's carry on. Now the video is designed or came out of the thought that I've recently had some comments and some questions that once again let me know that some of the things that I think are really obvious and basic are not obvious and basic to everyone, so I want to go through and do that and explain a little bit more. The comment was actually about a custom chamber and saying that it was a custom chamber because we'd had the throat pushed forward to allow for larger bullets, and that made it a custom chamber. Now I'll go through explain that that isn't what a custom chamber is, that your throat and your free bore and those bits and pieces, which I'll go through and explain in the video, are actually separate pieces, and actually it's not so much customizing a chamber as setting up a rifle and the details that go with that. But let's walk through it. To start off with, nice and simple, one of the things that I say is normal and expect people to know is a barrel, the understanding of a barrel, and the understanding and the definitions of the components. So I'll do it in a couple of different ways. I'll go through and break it down. I've got some equipment in front of me to show you the real hard facts of everything, but I'll also do some diagrams and bits and pieces to explain it. To start off with, what is a barrel? Where's it come from? What is it, that sort of stuff? Well, what I've got in front of us is the truck axle thing, with a solid piece on the end, with a hole in the middle with rifling in it, which is where all barrels start. No matter how it is, this is the starting point. A bit of steel. This one's actually tapered. This is a profile. You can see on the end of it here, there's a whole heap of writing on the end of it. This is a Krieger barrel. There's information on the end of it, but it's just a solid piece of steel. It's been rifled, so that means that the twist, the rifling, the grooves have been put through the inside of the hole. But other than that, that's all that's happened to this barrel. This is where they start. I suppose there's these components I'll go through, but what you're ending up with, a gunsmith or a manufacturer, whoever it is, you end up with this, this is the barrel out of my 300 PRC, which is where this is a bit more of a straight profile barrel, but it's had all the work done. It's had the chambering done, so the hole in the middle is still the same, except for it had a chamber put in the end of it. It's had thread. It's been machined down to where there's a thread on the outside of it. This also has a muzzle brake thread in the front, so a crown's been fitted or machined, so that means machining off the end of the barrel. There's a thread put on the end here. There's a thread put in here. There's a chamber put inside there. That is to end up with, as you normally see it, and you know it, well, in a rifle, but if you take your rifle apart, you'll find you have something that looks like this. An action, this has got a rail, it's got the bolt, it's got the barrel. Those are all those components and where they end up, where the bolt actually goes into the back of the action. Obviously there's the trigger on here, this is actually a Hauer. There's a mix of calibers and bits and pieces, but that's what you end up with. Those components actually consist of a bolt that goes inside your action, so that's the action without a bolt in it. And what you actually end up with, I'll reposition this stuff so it's a little bit easier to see and understand when we start to talk about a chamber, is that when you actually have if you remove the action, so you can't see it, what actually happens, your chamber is completed by the bolt going in the back of your barrel. It's held there by the action, but that's actually the end of your chamber. So the bullet sits in the end of your bolt, that goes in the end of your chamber, and inside there is the space for the bullet. Obviously you put a bullet inside there and that's how the gun goes bang, but these are the components that get to that place. Now I'll do some more drawing of that and explain more of the definitions. I want to quickly go through and explain some stuff that's going to matter down the track, but show some components that actually are used to do that. And to start off with, a gunsmith, a manufacturer, whoever it is, uses a ream to make those holes inside there. A ream is like a straight wall drill bit, I suppose. It's something that actually cuts from the sides, but that's what a normal ream is. That's just a 14mm ream. Is just a straight ream, not to do with gunsmithing, just a ream, what they look like. In a gunsmith fashion, or a chamber ream, you have something that looks like this. Now this has every bit of the chamber on there, which we'll explain in a little while, but this is for my 416 Barrett, and this is what a chamber ream looks like. And if you look at that side profile, should be able to see that against my black shirt, you can see the shape of your shell, of the casing, or the case. You can see the shape of that, where you've got the walls down the side here, you've got your shoulder, you've got your neck. In the finer details, if you look very closely, I think you should be able to see that in that camera, it comes down and there's a little step in front of where the case neck would be, and then it comes out here. You're not going to see the details and explain later, but that goes straight for a little while and then it tapers down to where it runs a very slow taper. This will be around a 2-degree taper, but you can get a 2-degree taper, a 3-degree taper, or a 1-degree taper, which is actually where we're talking about the lands. This is actually the end of the throat. This is actually tapering in and what your rifling actually starts like. Those are all the components that are on there. That's the big one, that's a 416. This is a little one. This is a 6.5 SAWM, or is this a 6mm SAWM? This is a 6mm SAWM. All the same details there. You can see the side of the case, you can see the shoulder, you can see where the neck is, and you can see the step down there that then goes into the free bore, and then you've got where it comes down into the throat as it tapers off into the rifling, which is, like as said, your lands. So those are what chambering reams look like. There is another process which you just simply have up to the shoulder and then nothing in front, and then you can get another ream that does the neck does the neck and does the throat in a different form. Or the way I normally do it, and like I said, the start of this conversation is you can get a ream that looks like this, which actually you're not going to see anything to the naked eye. It's almost impossible to feel, but this has a little straight section on it, and then it has a 1-degree taper that you can push in after you've done your chambering, and by very carefully pushing this further forward, you can push the rifling forward, which is actually pushing the throat forward for customing the throat on your rifle. And I suppose that's the bit I want to talk about on that form. If we look at a bullet, and we look at the case, so this is not what we got here, but all similar. This is nice and obvious. This is the 338 Lapua with a 300 grain Berger projectile in it, and that's the case. This here is just one of those cases, just a new case. So we've got all the same details, or, different size, but similar thing. We've got the sides of the case, the walls of the case, we've got the shoulder, we've got the neck, all the bits and pieces that you see stop at the end of the ream. In a bullet case, or when you do the reaming side of things, the actual chamber, the actual specific part we're talking about in the chamber, in the way of breaking it down to its bare basics, is really up to the beginning of the neck. Yes, it does include the neck, but the neck is a varied piece, which is, although it can be changed with chambering, it can also be changed after the chambering. So in my way of looking at things, the chamber we're talking about is up to that shoulder point, up to the neck point, I should say. Everything else means that that is the case, and that's when we talk about a factory chamber, or a custom chamber, or a match chamber, or a minimum size chamber. All those things are talking about all those bits and pieces from that point from the straight point of the neck backwards to the back of the bolt. All those pieces are the chamber, and where you can get different bits and pieces. Generally, when you're talking about a custom chamber, what you're actually talking about is something has been changed. And that's the likes of Ackley Improved, or all the different custom names can be as simple as they've taken that neck size and shrunk it right down. So they've changed, all the other angles are the same, but they've changed it from a 308 or a 7.6 millimeter down to a 7 millimeter, and that becomes a custom chamber, because it's actually, although the neck is involved with that, it's actually right down to that beginning of the shoulder is reduced down, so it's a custom chamber because of that. It means you're going to have to fire form your brass. It means you're going to have to do all the bits and pieces that probably make custom dies or get custom dies made, all those bits and pieces, but that makes a custom chamber. The same as if you change the angle of that shoulder and change it out like an Ackley improved thing, which takes it from a 60 degree shoulder to a 40 degree shoulder and things like that, allows for a little bit sharper shoulder angle, and it puts in to get more powder in it and all the different bits and pieces, or a shallower, all that sort of stuff. But it's a change as to where the person who's doing it is either trying to get more powder in it or make it more efficient or protect for throat erosion or all the things they can protect for, but it's changing it. And all the different changes you can imagine. And pretty much as we've got companies that keep saying they've come up with a new design, you'll find if you troll through all the different chamber prints, which is something I'll show you here, which is actually the drawing that's done for you to understand what that chamber is and to get a ream made to suit it. There's people like Pacific Gauge and Tool and different companies that make reams, which is this piece here, a drawing of that. And that design has all those measurements, every single measurement in there, so it can actually turn from someone's thoughts to paper to a solid piece that bores the hole in the in the barrel to create the chamber. So all that stuff there is where a custom chamber is. Now the bit where it gets a little bit complicated in the conversation is that when you go in front of that, the neck size, although yes, that can be changing your bullet size and changing the neck size to match, makes it a custom chamber. The actual specifics of the neck size can actually change in still a factory chamber. Oh, listen, I'll just come back one step. I mentioned match chambers, minimum size chambers, that sort of stuff. What we're generally talking about is a normal SAMI spec, which is a sporting shooting arms. It's an industry standard. It means that there is a spec that is designed as the minimum size that everything fits neatly to. Which will generally be a tiny bit larger than a match chamber. It's something so that all the different rounds, it's designed so that any factory ammo, you buy a box of factory ammo or you buy a box of brass that's just sized ready to go, it's going to go straight into that chamber. Once you go to a minimum spec or match chamber, similar things, slightly differences to them, is when they go down to the minimum sizes of what that chamber is designed to be, which means that if the brass is a tiny bit out or it's got a little bit of dirt or a little bit of dust on to a degree, you'll get to the point where it won't properly close the bolt. So not really great for hunting or for anything other than pristine conditions, because the brass has a little bit of room, which means it's going to expand a little bit when it gets fired, but it means that it'll go in any format. So that's the difference between there's a minimum spec chamber which comes right down to the minimum side of things, and then there's match chambers which there's some subtle differences in there, but it's really all the same thing. Sounds good, but it has some negatives to it depending on how you're using it, and much more for the bench rest shooter or the like I said, pristine conditions where everything is then sized perfectly, goes in perfectly, but there's no room for error whatsoever. A tiny bit larger really doesn't affect accuracy in any discernible level in a tiny bit, and going out to a normal specification, which is what most reams are actually set up for. They've got a little bit more in it. And then you can go to where there's military specifications and military conditions, which in two factors. One, tend to have a little bit more room for things to actually grow a little bit more, because they're not planning on reusing the brass. They just want it to fire and be able to load and function in all circumstances, whether that's in freezing or it's in the middle of dust or it's been hauled out of the river because it fell over in there. It can still operate and get with a bit of crud and crap around the place. It can still operate. And there's another thing that the old military stuff you'll bang into a little bit is that rifles that were made in the peak of large wars, where production had to be turned up to dial 17, and the rush of speeding things through means that some stuff got done a little cruder. And I suppose that's where I'll come back to a place in this as well, is that without all those specifications I talk about in the way of how a ream works, are very much about how a ream's used as well. Now this is a bit more gunsmith speak, and really for the rifleman, for the novice or advanced, doesn't really matter. The bit to take away from this part of the conversation is a good gunsmith is a very valuable thing, because how you use one of these tools is a very valuable thing. Unless you exactly center this unit when you're to the rifling as you machine it through, you can actually, by having it a tiny bit off center, means you get a larger chamber. If you have a tiny bit of swarf that picks up on the cutter as it's going in there and doesn't clean out, it actually puts a score in there, or can end up where it runs a bit more temperature and ends up with a larger chamber. From how smooth the sides are, from a little tiny score that's almost impossible to get to because it picked up on there, you end up with then a chamber with a little bump in it, which means that brass doesn't want to extract. Those are things of the quality of the system. High pressure flush through systems, perfect centering equipment, and the way it's used through a gentle hand on the wheels, in the way of all the different processes of making sure that it's not chattering, it's not doing anything wrong. There's lots of details to come to gunsmithing. It's a part that I do very little of. I don't have the hundreds or thousands or more hours of experience that are required to do this really well. So I use good gunsmiths to do this sort of stuff, even though I have lathes and bits and pieces and could do it. I would prefer to leave it to the expert to do that sort of stuff. And I suppose my comment is it isn't one size fits all. Not all the guys do it as well as all the other guys. So it is something to always consider when you're doing that sort of thing, and you're finding a gunsmith that works for you. Anyway, that I suppose leads into the next bit of the conversation where I was heading before I tangented off. You can, as when we started talking about the neck, there is, as I said, I think I said in that conversation, I'll say it again, you can get to where there is separate neck and throat reamers. So it's quite a efficient, I suppose, way, more business orientated way of doing a chamber, where you do the chambers all just as a chamber ream, and then you put in a neck and throating ream in afterwards. So it's a way some people do it. It means another thing needs to be perfectly centered, and it is the place where you can sometimes see a larger neck, because a normal nice fitting, or normal average SAMI or around there chamber with a large neck on it. It's the type of situation where generally, if that's happened, there can be some overspec reams that are used and things, but generally it's a case of, if that's not perfectly centered, if that's done a little bit rushed or a little bit hot or has a little bit of an issue, then it can actually open up the neck. That actually is something that doesn't really cause any shooting issues. It does cause reloading issues, or when I say reloading, it does cause resizing your brass. When all of a sudden the neck has to be pushed back in a long way because that neck is larger, it is something that can cause issues. So it's something to pay attention to and to get that right. Not too tight, not too large. I tend to prefer doing it all on the same ream. It's all centered, it all works in its own fashion, but it is something to keep in mind. And it is not talking about a custom chamber, it's talking about the neck size. So like I said, it's just in front of where we're talking about there. A little bit convoluted when you talk about custom chambers in the way of when I just change the neck size, but this is when you've got a SAMI chamber and the neck is larger. It can be because of the process I went through. A little bit of that stuff happened military-wise as well, but I suppose where I'm leading into is that piece there is something that actually changes on manufacturers. The same as the throat and the length of the throat. Once again, this is not talking about a custom chamber. This is talking about, well, actually all manufacturers will be different in that place. And to some degree, even different batches of exactly the same rifle will be different to that, because that is a bit that's set up and tooled for and not done as a robot. It is done as a spec, but you'll find it changes on things. So when people say, what's the overall length? I want to match mine to the same as yours. You really can't do it. It is way too fine in its details, and it changed a little bit. A couple of details to go here. It's not only the position of things, how far forward, and I'll go through that. You have your free bore, which is this piece of where you come out from the end of the neck size of the chamber, and you come straight forward where there's no rifling or anything. And then you start the taper that goes from no rifling to full rifling. Now that taper there, that is the lead, it's the lands, it's the angle cut place and all the different names that go with that. But that angle is different for different rifles. It used to be 3 degrees. I don't know if it was ever bigger number than 3 degrees. We used to 3 degrees and 2 degrees, and now we have 1 degree. 1 degree was really first designed, in my understanding, for bore riding bullets. So bullets that went right in had a little tough little like a drive band, an engaging band halfway down the bullet to be able to engage on there, and that was made at 1 degree at that point. I tend to like using the 1 degree, that very low angle, so that then I can, in my mind, as the bullet's starting to accelerate in there, it creates a little smoother pressure point, and it's a little nicer on the bullet as it starts to engage. But there's different schools of thought there. But what we're actually talking about when we're pushing the throat forward is we have a throating reamer that has that degree on there. And you set up this reamer, you center it perfectly to everything, and then you gently sneak it in, whether it's 1 thou or it's 20 thou or it's 40 thou, 1 millimeter, or it's 2 millimeter, or it's 3 millimeters. You push it forward to make it suit, and that would tend to be how I prefer to do things. Run a normal chamber ream that has a short throat, that is designed for as close as you'd ever, or as short as you ever want to make your overall length of your bullet, or as deeply seated bullet. And then I push that throat forward, get that throat pushed forward, whether I do it myself or I get my gunsmith to do it. And really this is not something to do with a hand tool. You can, but really perfectly centered and done in a well set up lathe is the smartest way to do that. It's a very important part of making that dead even as it picks up on the bore. But you push that forward to match the bullet you want. Now once again, I'd go back to the fact that we're not talking about a custom chamber in this form. And I suppose I'd reference the fact that it's not a place that is actually standard spec on almost anything. You'll find that different things do it different ways. From the minimum size, which is more made for a hunting caliber, where you're running a shorter, smaller bullet because they're running a smaller bullet for that job largely, so it's not the long range stuff so much. And then you don't want your throats a long way out. You don't want to have a 200 thou jump because you've got your throat a long way, or your glands a long way away. You pull them back in. So the average ream, when you do it in one thing, has a fairly short throat, or the lands are fairly close to it, which is the way I like to do it, because then I can go through with the throating reamer and push it further forward. But as said, the likes of some of the Howers, the likes of the Remington long range, they have their throat already a long way forward. This doesn't make it a custom chamber, as said. This is really about what it's designed for. So a Remington long range is made for heavier bullets and longer bullets, so it pushes it further forward. A lot of the stuff in the 6.5 Creedmoors was starting to push it out further because people were trying to run a heavier bullet in their 6.5 Creedmoor versus an old 260, where they were generally used more for hunting and they were running them shorter. But you can get them as long as it's not too old. It's a hard thing to do to a barrel that's been fired a lot. If it's run more than a few hundred rounds, it's all gone hard there. So it's pretty hard work on cutters and reamers to go through there. Much better to do when a barrel is a baby, because the metal is still cuts nicely and it's the nice time to do it. And I've been through, I'll put a link on there in a video as how to work out where you want that to go through. But pushing it forward doesn't make it a custom chamber, but it does make it suited to your bullets. Not hard to do, like I said, as long as you started it early enough. Can be done in older barrels. There are things that do that to go through and neaten things up, but that's very much a gunsmith question and to check things out probably first. But actually pushing that throat forward, and that moves into the places in the definition of what we're talking about there. The simple process is we're moving, that throating reamer has the free bore on the ream, then the angle, which is a set angle to that ream, whether it's 1 degree, 2 degree or 3 degree, it's set angle, and that ends up with the point in the rifling where that's going to move the full rifling all the way forward. So it's just moving your lands forward. The throat, the free bore, the lands, the rifling are all attached to the same thing, and they're all controlled by simply pushing a ream like this, set up in a lathe, perfectly centered, needs to be all perfect in its centering, for that is the lands you want them as even as possible, so you get an even pickup as the bullet engages, as it's scooting out there, but also to make sure that you're not opening up your freebore too much, which is all in relevance to pressures and how everything operates. But by setting up properly in a lathe, pushing these further and actually winding them in, well, you actually they're a cutter, so they're spinning at reasonable speed, and they push in there a little bit. I then take the barrel out, check it with my bullet, make sure it's all in the right places. But that is something I suppose I want to come back to where I started in the conversation. This is a process that is very much about setting your rifle up to suit the bullets you want to. And no, it's not in a custom chamber. A custom chamber is all in the stuff prior to that. It's all in the thing. Like I said, really, as much as the neck is in the chamber, the chamber changes are all just at that point of the shoulder, where whether you've just simply, it's I shouldn't say undersized, where it's just simply the 6mm saw like we've done, where it's really the same, all the other chamber shapes are the same, but it's still customized because it's running a smaller bullet, or it's got a different shoulder shape, it's got a different angle or a different, where it's sharp shoulder, or it's got a round corner, or it's got all the bits and pieces. That's all in the custom chamber, all in design, some of them very smart, some not so much, but the custom chamber is prior to that. Your neck size should be a set size, but that's a place that actually is happening when you're chambering, but is more just the neck rather than the chamber we're talking about. And in front of that, the length in there, your freebore, your throat, your lands, where they're positioned, all that sort of stuff is really always going to be different, and something to keep in mind. And I suppose the other part of this story is to say that when you're trying to copy someone's data, even though you think everything is exactly the same, it changes from rifle to rifle. Even in exactly the same rifle with exactly the same barrel with exactly the same, it still had to go through its own chambering process. So even if all exactly the same specs, all exactly the same processes happened, the way that metal actually cut, the way it actually cleaned, the way it actually happened can still make slight differences, and it means that even though everything seems to be identical, they are always individuals. They're always their own personality, and they always need to find it, because it is a real, no matter what, no matter how many millions of them they made, every single one of them had to go through this gun test process of having a ream put in there, and the cleaning and the cutting and the things that happen with that particular piece of steel on that particular ream on that particular day at that particular temperature ends up with that particular result. So, what are the upshots of this video? Really, these are the components. That's how they work. They always work this way. You've always got to find out what they are. A gunsmith is not just a gunsmith. Finding a good one, finding one with the best practices, finding one that does things well is a valuable thing for a precision shooter to make sure that all works and you're talking in the same language. And I think that's about it, probably. Listen, I hope that's of some value to people. I hope that makes sense. Drop any questions or comments you've got below and let us know. And other than that, thank you very much for checking in on us. Hope you enjoyed, and we'll catch you next time.